Hey guys, my name is Tom from Filmatra and welcome to Program With Me, or however you want to call it. Today I'm going to, this is basically part 2 of the series of DIY Talon grips, or Talon jaws, however you want to call that. And we are going to be programming and later on machining this whole assembly. Sorry for my fusion, it's kind of bugging out. This whole assembly, and this is what we're gonna do today. We're gonna program this jaw. It's gonna be made from aluminum, and then the little hardened steel bars are gonna get put into here later on and machined separately. So let me start. So what did I did in preparation? I put in my jaw model because my origin is vice. G59 is what I use. G59 work offset is what I use, and it's basically here in the middle of the vise, and this is Z, so it's on this plane right here. So that's why I always model in the jaws. That this makes it much easier to avoid, you know, cutting into the jaws, because that's why I'm making these jaws, because I did that a couple of times. So I'm kind of trying to learn a better work process to get that. And so I put in my jaws and I modeled the stock that I'm going to be using like so. First op is going to be from this side, so Z will go, this will be Z0, basically like that. Like this exactly is going to be op 1, so Z goes up. This is going to get faced off, this is held down by like 4 millimeters, and these jaws need 3, so that I've got some spare room there. And basically that's it. I aligned these so they sit correctly against that, and that is it. So let me pop into manufacture, and I'm gonna show you my process of how I do this. So first I know this will require 2 ops, so I'm gonna make 2 manufacturing models. I'm gonna edit manufacturing model number 1, and I'm gonna get my origin here. So I always start a sketch on the face here, that's machine, that's the precision face basically. That then I project these 2, draw a line, point in, oh, that would actually be wrong, find the middle, boom, done. Finish sketch, finish edit. We've got model 1 done. Let's go into model 2, edit that, and now here starts to get more involved. So we're gonna be not using the stock, so I'm gonna remove it completely. I'm gonna work with in-process stock, and don't move this model. The model has to stay at the same spot, otherwise that's not gonna work in between the setups. So I'm gonna take the align tool, and I'm gonna align the jaws to here, and now they're gonna be 0.3 millimeters, because this surface is lower than this, and it's gonna be sitting on this, so that's not gonna be correct, but I will move that later. So I'm gonna align these. Actually aligned that wrong, okay, sorry for that. Let me just quickly move this. I do remember the way I was, why is it so weird? Okay, give me a second, it's kind of, what? Oh, sorry, I picked the wrong tool. I didn't pick align. That's why it was acting up. Little tip: if you hold Alt while selecting, it makes it easier to select these, you know, spots where it might like pop into here. If you hold Alt, it's gonna be much easier. It doesn't work as well as it normally does now that I'm showing you, but it usually does work great. Since there's going to be some heavy roughing, and I don't care about the surface of these much, it doesn't have to look amazing. I'm going to just hold them in the serrated jaws again. Although I do think it wouldn't be, actually, scratch that, sorry. I'm going to hold these in on the smooth side. We've got 20, so we need to move this 4 millimeters. Will that work? I don't think I'm gonna be able to make this spot. Let me see. I think that's actually doable. I'm gonna see. Worst case, I change that later. So it's gonna be held like this. There's gonna be a parallel right here. It's 21mm tall parallel. And since I have that, I can capture position. Again, I add the sketch. I project these, construction line, point in the middle of that, finish, we're done. So that's model 1, model 2. That is the correct way. So the model itself doesn't move, only the jaws and the fixturing around it does. And let's pop into here. So I've already got this set up. I copied it over, but in short, we're gonna go into here. I pick my machine. I select orientation. I go origin, selected point, select the WCS origin. I'm actually gonna select the manufacturing model here first because it won't let me without it. This usually gets automatically selected, but since I already copied it over, it doesn't. So here we check and it's on the flat bottom of the jaws. That is correct. We select the model, so I'm gonna have to get this like so. We do from solid, so hide the model, select original jaw, and then stock. I'm gonna go from solid, select, and I'm gonna select the model stock that I already modeled up. And fixture, we can select these just cause it's better in case there would be any kind of hits with like a drill or something. And then my WCS is G54. That defaults to G54, but I actually had it changed, so I wanted to check. And that's everything. So we do OK. And let's see. We've got a ton of errors, but first off, it gets roughed with a face mill, 50mm. It gets cleaned up with a large fly cutter style, just one insert in like a big face mill, 80mm face mill. That makes the surface super nice. Then there's an adaptive with a 10mm tool. Some helix there. Not much more to say. Then we've got a contour with an 8mm. I believe that was this one. Gonna fight us. No, actually, sorry. That's the 10mm tool. That is the outside profile of the jaw. So I'm gonna select silhouette. I'm gonna do outer loops. Okay, okay. See, that will go around. I actually do want to change this up a little bit because you can see the depths. Once we mill this, you can see the depth doesn't go all the way down to the model. So I'm actually gonna pardon me. I'm actually gonna change this up a little bit, and I want to do model the bottom height. I want to set to model bottom. I'm gonna do minus 0.5, and hopefully that picked correctly. Yep, that worked. Okay, here I'm gonna do the same. Sorry, heights, model bottom, minus 0.5. Done. That will contour beautifully around that. So then, adaptive. Why is the adaptive? Oh, right, top reference. I'm gonna select this as the top. The reason why I'm selecting it here, I'm sorry I'm going through this fast. Because I already have it set up, I'm trying to not waste much time. But the way I have this set up is so it doesn't try to, you know, machine these parts or these flats. I have the top set to here -5, and that also saves me time that it doesn't, you know, try to do stuff here. Let me actually show you how it looks if I do 0. You see, it has these weird moves around. Like, what the hell is this? Like, why would you machine this little part? It's completely useless. So that's why, you know, I'm trying to kind of keep it under control a little bit by setting the top to -5. There we go. That's a lot cleaner. If you really wanted to save time, you could do most on the stay down level, and it's instead of, you know, retracting a couple of times, it's just gonna move like this. Might save you a few seconds, but it's nothing significant. Here you can see also there's some weird links and stuff, but I don't care, it doesn't really mess up the part in any way or mess up the surface. So then we have the contour, and that will be this pocket, and the bottom will be this. Okay, super simple. It just does, actually, I am incorrect, sorry. I know I'm jumping all around this, but I really don't have much of a choice to make this any better. There we go. So it's this, and the bottom is going to be this spot. There we go. Why did it not mill this part? That's weird. Oh, because I did not select it. I'm gonna select close chain here. That's gonna fix it. Yep, there we go. That's perfect. Then we have the, let me actually do a quick check. I've got this 5.5 basically. Yeah, good, okay. I've got, that's the CAD for the soft jaw that I've already machined, so I'm just basing it off of that. Okay, then pocket, I'm gonna select this. I'm gonna also check, because I know, yeah, maximum step over is 4. That is stupid. I'm gonna set it to 7 because it's an 8mm tool. I realized that I think it touches the wall slightly here. I'm gonna have to watch the simulation later. But I was setting the step over wrong for pocketing, so. And then we have the interesting contour here. I will show you that in the simulation in a second as well. And we've got some chamfers. I believe they were something like this. Okay, guess that's why I split them up, right? That's a very big chamfer. Let me check really quick. Sorry, I'm running around so much with this, but I am trying to remember because I haven't had this file open for ages at this point. So this is gonna be the outside chamfer. Don't do that. Okay. Sometimes Fusion doesn't want to listen, so you gotta, you know, kind of force it into listening, like so. That should do the chamfer correctly. Yep, that's good. I will do the small chamfer on this whole thing, basically. Let's see what Fusion thinks of that. Yeah, that's what I expected. It's fine. It doesn't matter much. End mills don't leave much of a burr. So let me show you the simulation because I went through that very fast. So I see I've got some collisions, but I'll show you. So here's my facing op. It's just like a very small depth cut. I'm not sure. I think it's like 0.5 millimeters or a millimeter. So not heavy at all. 7 seconds, easy. And this is the cleanup. I'm leaving from the face, I'm leaving 0.1 millimeters, and that then gets faced off like so. Then I have the adaptive with the 10 millimeter tool. That's a fairly heavy cut. It's 15 millimeters depth of cut, and it's 5 millimeters width of cut. So that's pretty solid. It sounds amazing though. This tool has been seriously great. And as you can see, this is still not finished. I have stock to leave set on there, so I'm gonna speed this up a little bit because it's gonna take a second. See, there was this weird jump, non-cutting jump. Then it does the full depth. And okay, let me slow down here. Why is it saying the shaft glides? Oh yeah, I got it. Oh my god, that is a solid 0.5 millimeter of collision. I'm gonna change that in a second. Let's say that went well. It wouldn't have probably, but I'm gonna change that once we finish watching. So here I'm doing a little adaptive that clears out anything that the 10 millimeter left behind, and then a contour all around this. Then a pocketing up. gonna slightly hit that, but I think that should be no problem. Okay, and then this crazy thing. This is, don't get inspired by the way I did this, because I am sure it's wrong in many ways. Let me pop into the op again. I got kind of messed up. I'm gonna do a section analysis. I'm gonna set it to half of that. Let me turn that on. Okay, so check this out. This thing here goes down. Jesus Christ, why is Fusion so laggy today? And then it starts cutting like so. Just fairly small step over. It's not crazy, but here you can see it isn't the best for the tool for it to go straight into a corner. So I'm slowing down the feeds. I'll show you how to do that in a second. In these corners, I slow them down, and it does a couple of passes. It's aluminum, so I can afford to do stuff like this, which is pretty stupid. I'm actually going to do a little edit, I believe. I could add a few roughing passes because I want to have it cut air. So I've got two things to edit here first. Let me show you. I'm going to add a few step overs here. And then feed optimization is what I was talking about. The little yellow corners is that it slows down to a regular feed rate is 890 millimeters per minute, and it slows down to 600 in the corners, which is fine because that's fairly helpful, because when it's being very bogged down, this really helps. I have a slight amount of stock to leave because I just had to set that to make it do it accurately. Let's watch the simulation now if that helped anyway. See, the first pass is always a little painful, but I do believe that helped a little bit. See, these are subsequent ones are very small. Just the first one is pretty heavy. And here's the finish one. And see, it says it left this here. Super weird, because I know for sure it did not. So yeah, it might be. This might be just Fusion being weird, because you can see this angle. Fusion doesn't say it's a 45 degree, but I believe it is. It won't tell me. What's the angle between these? Okay, whatever. I know it did turn out well, so that's just an oddity. And I want to change the contour around it. It's gonna clean it up. I'm gonna do it in multiple depths at 15 millimeters each. So that should do 2 passes. Yeah, that's great. We'll turn off analysis. Let me redo the adaptive here. And now the sim is done. Let me watch it. So, face top, clean up the top, adaptive with a 10 millimeter tool. Do the inside as well, roughly. I do think I have one operation I missed. We will see in a second though. Okay, the contour works perfect. This adaptive cleans up the corners that the 10 millimeter couldn't reach. Pocket, dovetail, and then 2 chamfers. Yeah, as you can see, everything is machined except this, and I seem to have somehow managed to change something with the with this tool, the way it exits. I'm gonna actually make the vertical lead-in distance and radius 1 millimeters in an effort to save that, which didn't work. Okay, it's the lead out, so I'm gonna change this to not be same. I'm gonna do perpendicular maybe. Yep, now it hits this. I am going to, let's try 0 degrees. Yes, that seems to be fairly okay. Yep, nice. Okay, so that's fixed, and I need to do a little pocketing up on there, and I'm not sure why, but think it might have been, yeah, it might have been selected here. So let's do it here. Yeah, that is it. I saved a lot of time reprogramming it now that I know more of, you know, how to program this stuff. Let's skip over. We seem to have no collisions, at least Fusion tells us we don't have any. Nice, that'll just face it off beautifully. This should work without touching anything. Let me actually watch this. I usually watch this at fairly slow speeds, but right now, because I've already programmed this, I don't need to be crazy careful. But let's see how it exits, because that's going to be important. I'm actually going to do this instead of the holder. I'm going to do shaft. This is super handy to use. I also always basically run in comparison. I never ever use any other stock colorization mode. It's gonna cut it like that. We're getting close. This should be the final. Yep, that's fine. Tons of clearance around that. Okay. Good, so that is basically the first op, and now the second. So let me edit the setup. I will do manufacturing model 2, okay. Model, select my model. Origin, selected point, select WCS origin. This is how it's gonna go in the JAWS. Stock, I'm gonna set to from preceding setup and continuous machining checked. It will say, hello, I cannot verify that the stock is transferred correctly. I want to ignore that, okay. And let me just quickly generate these. You press Control G to regenerate it. And we've got an adaptive that is, for some reason, yeah, right, okay, so I'm gonna set some of the bottom heights that are unset right now because I copied it over. I am very interested in how this will turn out. What was the contour doing? I believe it was this. Okay, parallel, touch surface this, okay. Another invalid bottom. I said 0.1 or something crazy. How's that gonna look? Oh, that's decent. I think I have a chamfer up here as well. Let's see, that's 0.25. That was this. Then I have this chamfer, which is 0, and I set it just for this line. That is like crazy. Look at this. I'm gonna have to add it some extra 5mm or so on here. Passes, finishing overlap. Wait, it's not finishing, sorry. It is in here. If you edit this, you can do a start and an extensions, like so. Let's watch this, because this is how I did it before. It's absolutely insane, but it works. So you'll see. It's crazy. Yeah, you basically go like this. Just like 0 clearance, and just clean that up. Boom, done, easy. I'm actually gonna, it never collides, which is amazing. I'm actually gonna probably, I think I'm gonna do this ball at a larger step over. I'm gonna do 1mm, save some time. It's gonna make this surface kind of ugly surface, and I'm gonna do the chamfer, and I'm gonna move it up here. I'm going to, let's try to do it this way. So I'm gonna take the chamfer, I'm gonna keep this selected. I'm gonna go into, let's go passes, chamfer width. Let's do, oh, this won't work. This won't let me adjust it. What I'm actually gonna do is I'm gonna make I'm gonna go into the manufacturing model, I'm gonna make a sketch, and I'm gonna do a rectangular pattern of this line going down. Let's make like 3 or something. That should work. And then if we go into the chamfer and we select these, theoretically that should work, right? Okay. Judging by the passes, that seems to work. I'm gonna have to move this up. The simulation sometimes isn't very accurate, so I'll actually show you this. If I simulate the parallel as well as the chamfer, it should show it better. Yeah, but that's basically what I'm going for. Let's pop back into the manufacturing model. Edit this, edit this. I'm gonna set to -4. Actually, -5. Should be good. I can just regenerate this. That should take care of the whole thing. Okay, let's simulate the whole thing now. So, we will rough the top. Now, I believe, because I'm using the smooth jaws, I think I'm taking just a 1mm depth of cut. I don't want to overdo it. I've had stock move on me, and with the face mill it's not very comfortable. Then cleans up. Adaptive, again 10mm, my go-to rougher basically. We'll rough out the slot. I'm actually going to finish the slot in a separate operation. And then it will rough out this. Okay, I can see that this isn't finished, but this seems okay. Okay, and here you can see there's still lines on it, but very, very small, if any, so that should be fine. Yeah, the chamfer tool in 3 passes is gonna just do this. That is perfect, basically. I'm going to edit it, and I'm gonna do a couple of things. So, first things first, I'm gonna delete this contour. I'm gonna hide the sketch so it doesn't confuse us. And let's work on this. I need to drill the holes, I need to make the slot, and I need to probe the slot so it's accurately exactly 20mm, which it won't be by itself. So what I'm gonna do is I'm gonna start with a pocket. Let me show you my tool library. There we go. So I'm gonna use the 10mm, I guess. That should be perfect. And I will select these 2 pockets. Let's do OK. Easy. Let me actually quickly select, set this to the correct step over, not 5, but let's do like 8mm or something crazy. There we go. And I will do stock to leave. Radial, I will leave 0.5, and axle, I will do 0, because that's going to be cleaning up the bottom face. Done. Then I will do a contour with the 10mm. Pocket, contour. I'm gonna reorder this in a second, just give me some time to clean this up. Okay, so another contour, I just duplicated that, and I'm gonna do this and this surface. And I'm gonna do an important thing, and that's here. I'm gonna set where, compensation to where. Let's do OK. Actually, there's one more thing I want to do, just in case. I will do 0.2mm stock to leave on the walls, so that will still have some material left over. You can see there's some extra. Then we go into inspection. We do probe geometry, and we probe this. We go update toolbar, select this contour up, do OK, select my probe. Actually selected its channel, which it isn't, and it's giving me an error, which is the approach is too big, so I'm gonna set it to Y channel without island and do a 5mm approach. That should be correct. And then we duplicate this and we move it under the probe geometry. And we change this to have 0 stock to leaf. So, kind of speeding through it, sorry if it's confusing, but it's already a 30-minute video, which is insane. So let me jump through and show you. So, ignoring the chamfers, here we go. So here's the pocket that we just programmed. Super simple, just pockets, leave 0.5. Then here we do another pocket, just again leave 0.5. This will cut it to size because we don't care about precisely. It doesn't have to be exact. And then I'm actually doing something wrong here because check this out. We have before the op. Oh, I'm sorry, I'm pressing the wrong button here. We've got this step, so that means that this is 0.5, this is 0.2 or something. So my adaptive, this adaptive, should have 0.5, 0.2 at the floors, for example. Then if we click on the pocket, once the stock in process loads, you can see that there's no step. So we just fixed that. I'm gonna set this to 0.3. Actually, sorry, that's the pocket. That's not what I wanted. The contour has to be set to 0.3. I think I've already set it at that, so let's check it out. Jesus Fusion is laggy for me today. I guess it's because I'm recording. PC isn't able to keep up. So face, rough, ball, chamfer, chamfer the big surface, pockets. Yep, that seems about right. Then contour this. Then contour these slightly. Yep, leave some stock. Great, that is perfect. Then we're gonna probe. It's gonna tell us on the control. You'll see that one once I post the CNC part of this. And then we just do the contour to exactly 20mm. What we can do is we can do another probing pass here to probe this again. Y channel, and we're not going to do anything, we're just going to let it tell me what the size is in case that isn't correct. So now let me just do one quick change, and let's do the chamfers last. I'm gonna do it like so. I don't necessarily need to do the ball here, ball tracking. I could have just taken it with the chamfer tool. But let me show you how it looks. It has like solid steps. I don't want to have the tip of the tool have to cut it, so that's why I kind of rough it out with the ball and then chamfer. I would like to also have this say optional stop. Let me actually learn this. Should be manual and C, optional stop. Let me just quickly read if it's... Oh my god, there is a lot of stuff. Okay, let's do optional stop then. So that's gonna go right after the probing. There's gonna be an optional stop so I can change if I want to. We'll see, that's cool. Never tried this. And I'm just missing the drills and tabs. Let me go into milling then. Let's do drill. Like 10 diameter. Because this has to be fairly consistent, I'm gonna spot drill it, which I usually don't do. And I usually do here bottom height to chamfer with 0. Boom. And it's gonna just do a big divot, however you want to call it. And then we do drill, select same diameter, What diameter is that hole actually? Does it tell me anywhere? What is the diameter? Ah, it's a 5 millimeter per liter, right? 4.2, yeah. So we need a 4.2 drill, which I don't currently have in the machine or in the library, I think. Let's just set this up. I will change that later on. It should be to the correct depth, and then we'll do drill. We're gonna do a tap. Yeah, I'm gonna save myself some time. I'm gonna tap this because I'm gonna be making a couple of these. So M5 tap. It's 3 flute. It's gonna be 5 millimeters in diameter. I'll leave it roughly the same thread pitch. Let me actually check M5. Let me quickly Google up if I'm correct on the standard. I think it's 1.5 or 1 millimeter or something like that. Actually, it's 0.8. Okay, I'm wrong. This is important to set up. Very important, actually. And rest can remain the same. I always tap at 1,500 RPM. I'm gonna set this to be like tool, whatever, 19 or something. And select that. And do OK. Actually, I need to pick this. Select same diameter. Done. And that's it, really. Let's do a little thing I do. I always click on all setups. I do simulate. It's gonna tell us a lot of collisions, but this way you get the most accurate in-process stock model possible if you do it this way. So you can then view the whole thing. Actually disable the model completely so we can take a look around it. I also usually just run it at some higher speed, but not like skip over, because this is the way to force Fusion into doing the absolute best quality. And you can see there's not a single face that would have anything left over except this little burr, but I think that's going to be fine. Yeah, chamfers all fine, holes are fine. This huge chamfer should look great. Nice. That's it. That is actually it. So then I would just post that over, and yeah, that's how I programmed. That took me 37 minutes, a lot longer than I expected. Hopefully there's somebody that uses this as a podcast or something to maybe learn a little bit from Fusion. Granted, I'm not that experienced, so Jesus Christ, time flies. Yeah, that is the jaw. And that is the part 1.5 of this series. It's not essential to watch this, basically. So if you just did, thank you for listening to me blabbering about I have no idea what. I completely lost track of time. Anyways, that's the part, and we're gonna see how that turns out if I messed up anything. I do know one more thing I want to do before we end this. I don't have any probing set here. So right now the Z height is fine because that is set correctly, but the x-axis after facing, that needs to be set. So what I'm gonna do is I'm gonna do setup probe WCS. I'm gonna tell it to probe somewhere like here, and override driving VCS overdrive 6. Okay. I do actually wonder. Okay, oh, good. That's gonna just probe here, and that I want to do after the face. So now if we regenerate it, it's gonna face it. It's gonna clean it up, then it's gonna probe the stock that's been machined before, so that's gonna align it exactly how it should be aligned. yep, that's it. That's everything. Thank you for taking so much of your day to watch this, and in case you did watch it to the end, I hope you have learned a lot, because I hope it was worth it. Yeah, that's it. Signing out. Take care. Bye.